according to last classification I read by Dr. Ario, there are 5 groups, and type 5 includes some monofocal plus lenses such as RayOne EMV. This 5th group based on central zone variation. Actually, according to me, in this classification, type 1, 2, and 5 should be named as non-diffractive ED of IOLs. Because all this group have meaningful depth of focus range. What about this instead of monofocal plus? Because I don't like this nomenclature because it doesn't have EDOF. What do you think?
I agree with you 100%. The order between monofocal plus and EDOF is so variable, and you can get monofocal plus, but the depth of focus is not dissimilar to, say, symphony or even vivity, and it will just vary, and it's just so arbitrary. You know, when I conceived this lens, I conceived it as EDF, or extended depth of focus. So for me, the attempt to categorize monofocal plus EDOF is going to get us in a mess because it's arbitrary. And sure, I don't think it's necessary to add the other two. You know where it crept in? There are certain lenses that in the US has defined as if you have certain criteria, you can be labeled as EDOF, and then for the companies, the reimbursement is higher. But this has nothing to do with science or us as clinicians. It's just an arbitrary line that if you can fulfill their criteria, but some companies don't bother doing that, and so I don't think that's a reliable classification. And I would rather, as you suggested, diffractive versus non-diffractive is a much more elegant. And even then you can argue, is vivity diffractive lens? Well, probably yes. but at least you can argue on science and not on just arbitrary definitions.
The second question, as I showed you, related with angle kappa or angle alpha. Actually, we have this question very often. Do you think these non-diffractive lenses have advantages over trifocals because they don't have strict central zone? I think except vivity, it has 2.2 millimeter. But can we say it has advantages, especially for RayOne EMV? Is it a restrictive factor, as you know?
It's a very RayOne EMV, positive spherical aberration, is quite robust to decentration of the optic.
Yeah.
And so it holds up quite well, and you can, you know, there's nice graphs to show you that when you decenter an optic, you impact the optical performance, and positive spherical aberration is not very sensitive to that. The problem is, of course, another non-diffractive optic, which is negative spherical aberration, is exquisitely sensitive. So you have to specify the optical principle. Now, angle alpha and angle kappa are not the optic being decentered, but it's in some ways is the optical system is not well centered. Now, I've never seen a study which has looked at, and you can do it on the optical bench, you can probably get the system perfectly aligned, cornea, lens, and then you can offset angle kappa and angle alpha. I think, similarly, it will not be so sensitive to those corneal, if you like. You don't think of angle kappa and angle alpha as misalignment, but it is really kind of misalignment. And that would be worth doing in the laboratory bench, because you can do it with misalignment of the optics, and you can plot the impact.
Sure.
You could do it in a laboratory quite easily, but you're still manipulating the optics. Just change the angle alpha, and I think instinctively it would be fairly resistant.
How much positive spheric aberration is available? I would like to dream.
Sure. Look, it obviously depends on the pupil, and if you have a 5 mm pupil,
Sure.
and you check the spherical aberration, it will be greater. Now, of course, the EMV optic, the spherical aberration diminishes towards the periphery, so that performance will hold up as you get bigger, but it is still varying with the pupil. In actual fact, if you look at a normal pupil size, say 3 mm, which for post-cataract patients is quite common, or less, the amount of spherical aberration is not that much with the EMV.
Yeah.
Maybe 0.15, maybe 0.2, but it's not 0.4. Okay. If you then look at the spherical aberration and say a 5 mm pupil, it will be much more. Now, of course, our pupil size is continually changing as we go in different environments, as we look up close, and so the amount is also going to be quite dynamic. But the same holds true for the human eye. With no EMV, of course it's variable and it's changing. Surprisingly, we don't really see that. So our cortical system is quite elastic. When you say to me how much is in the lens, you have to specify at what pupil size. But it's not much. 0.14, 0.2 maybe, it's not very high.
But you mentioned with in vivo aspiration. Actually, I remember a study by Dr. Schmidt from Germany, which was published in Graphes. It was in vitro. According to this study, average spheric aberration was 0.16 micron for the central. Do you know anything about the decrease to the periphery is linear or step by step? Actually, maybe this is the answer for angle kappa or alpha question.
Yeah, so it is linear. It will vary with the radius from the center, but it's completely smooth. It's a continuous curve, so it will not change abruptly. But of course, it will change as the radius goes out. And the only distinctive feature is normally as you go out and let's say gets more, because more of the optic is exposed, as you get towards the periphery, it's no longer linear. It's diminished.
Right. Yes.
But it's just one curve, and it's interesting that it's not just fourth order aberration, spherical aberration. It's fourth and sixth combination, and fourth and sixth, because that's how you can diminish the impact on MTF. And each lens in the power range has a slightly different curve, because what you need for a lens, say from 10 to 15 diopters, what you need from a lens from 15 to 20 diopters for an optimum curve will be different.
For my third question, related with post-myopic LASIK patients. Probably one of the main problems because of the positive spheric aberration. According to me, or for my knowledge, if you did for -3 diopters in LASIK, it induces 0.1 positive spheric aberration. Is there any cutoff point if we would like to do RayOne EMV after postoperative LASIK patients, or we shouldn't do any time in any case?
No, I think you have to be cautious. It's not just the amount of myopia, but it's looking at the size of the ablation. So if you look at the topography, since a very small flat zone, like some of the earlier LASIKs where the zone was quite small, I think one should be cautious. I think it was a modern laser, it's -3. You probably don't have to measure it, but anything which looks a bit untoward, then I think you should either from Tracy, from the Pentacam or something, try and get an idea what the circular aberration is, and err on the side of caution. That's how I would approach it. I hear many doctors say, no, they think they can use it for everything, but I would be more cautious. And particularly, I'd be cautious in radial keratotomy because the circular aberration can be very high. What is the level? I would think if you have something like 3.4 before cataract surgery, then maybe let somebody else try. I would be cautious. I think 0.1, even 0.2 is fine. But if you have 0.4, then yeah. But you would be cautious about a multifocal in that circumstance as well.
Okay, actually, I'm asking this question for another reason, because I have one unhappy patient after RayOne EMV surgery because his non-dominant eye have -1 diopter myopia, and he feels the difference, and he is unhappy. One of the solutions, I can do LASIK surgery for example, only half diopter. Actually, I scare because it may cause a meaningful positive spheric aberration and may decrease his vision. Should I do or not?
I would be quite happy to do that. I think the benefit from diminishing the low order aberration,
yes,
would outweigh any theoretical impact of inducing. I think with a modern laser, -1,
yes.
I don't think you will measure it. I don't think so. But tell me, he's unhappy because his other eye is planar, or his other eye's distance is
the otherwise plano, very good, 20/20p, every distance good, including near. But the left eye, his non-dominant eye, myopic, and he is very unhappy. I had to prescribe far vision glass for him. He's using always. So I mentioned him about LASIK option, but I am undecisive. But I didn't measure his total spheric aberration. After I will decide. But actually, I am looking for a cutoff point for positive spheric aberration. Maybe you can say if it is over 0.40, don't do, under do. But I don't know.
I think 0.1 would be fine. But the question is, it's very unusual to find an unhappy patient
Yes.
with -1. So his best corrected acuity is good. It's fine. There's nothing.
Yes,
Something else.
20. Very normal patients. He's retired dentist, and there is no problem with glass. He can use glass, but he doesn't like normally.
So, I mean, one thought is to put a -1 contact lens and
Yes.
let him experience what he will lose from reading before you do anything to him.
I tried. If it decreased to minus 0.50, he would be happy, I think. I tried.
Really? Okay. He would swap some reading.